In this project, we are going to apply our new learned constraints and their strategies, along with other ways of constraining, to make a tire and a wheel. This tutorial is fairly complicated, so I suggest that you take your time to understand everything, especially the sketches. We're going to start by making a sketch on the side plane, like this. This sketch is going to be our most advanced sketch yet, and is going to have a lot of constraints that you will need to know. Create a vertical construction line from the origin that is 50 millimeters tall. Above this line, we are going to create a rectangle that is 15 by 30. Now, of course, this rectangle is unconstrained, so we want to constrain its position. We're going to apply a midpoint constraint to the top of this line. Now it's fully constrained. We're going to, so once we do this, this centers the rectangle for us. From here, we're going to make this bottom line a construction line. So if you have a line that's already a normal line, you can click on it, click on the construction line type, and we can see that it's now a construction line. From the bottom left corner, inwards 5 millimeters, we're going to create a 5 millimeter line, like this. Make a vertical line downwards, but don't give it a dimension. We are going to apply an equal constraint between these two lines to make this bottom line also 5 millimeters, meaning it is fully constrained. We're going to then repeat this on the other side, but instead of applying more dimensions, we're just going to apply more equal constraints. So we're going to make, if you select all of these lines using shift clicks and then apply an equal constraint, it will make them all equal to each other. Now we're going to apply an inwards offset of 2.5 millimeters. Start by dragging it inwards and then type 2.5. Now when we make an offset, the edges of the offset are always unconstrained in terms of their length. So what we're going to do is we're going to apply 2 more lines like this and make sure that they're horizontal. We don't actually need to define the distance for these lines because if it's horizontal, that's already defining the length. Since tires have some curvature, we're going to add arcs to the outer edges. To constrain an arc, you have to basically define its radius and midpoint. Its midpoint shows up as this point, so we have to constrain them. Make a construction line like this, going from the upper midpoint of the inner offset to the outer rectangle. And then we're going to apply a coincident constraint between the arcs and this construction line. When we do that, we will see that it fully constrains the sketch, and now our arcs are constrained as well. We're going to want to make this one continuous profile, so shift click, select both of these parts of the rectangle and make them a construction line. Now we can see it's one solid profile with no sections that are different profiles. It's all connected. Now we're going to create the treads. To do this, we're going to create 3 rectangles all along the top. The edges, you're going to want the lower left edge of the left one to be coincident to this point, and then the rightmost to be coincident to this point. For the center rectangle, you're going to apply a midpoint constraint to the top of the rectangle. Basically, so the bottom line is midpointed to the top line. That will make it so it's always in the middle. We are then going to select all three of these edges and make them all equal, and then all of the top edges by shift clicking and make them all equal. Now, all we have to do is define one of the rectangles, and it will automatically update the rest of them. So make one of their heights 1.5, and then one of their lengths, make it 5. You can see that now all of the rectangles will have the same dimensions. If we click on this one, and then look in the bottom right corner, we'll see its length is 5 millimeters, which we have defined by defining this one. So if we wanted to come back in and change our treads, all you have to do is change these dimensions, and it will update both, which you can see by just editing these tags. Oh. So if I make this 7, you'll see it updates to 7, and I can Control Z and make it go back to 5. Now we're going to create a second set of rectangles within these rectangles. Now we're going to midpoint them. This is the intersection of the treads. One thing you can also do is you can hold down your mouse. If you hold down your mouse, you get this option where you can then select through different lines that are on top of each other. It also works for points and arcs. We're also going to apply another equal constraint to all of these smaller lines. Like right here, you could see how I use that. Now, one thing to note is that we don't have to define the height of these rectangles because the upper corners are coincident to these to the previous rectangles we made. So if I made this 2, I don't have, like, it automatically updates. I don't have to go back in and then change the height of these rectangles. Now we're going to select the top edges of the smaller rectangles, and we're going to make it 2 millimeters. So we can see that that updates it on all of the rectangles. So we basically were able to define all of the treads on top with only 3 constraints, or with only 3 dimensions, and we were able to define the rest with constraints, mostly equal constraints and midpoint constraints. And you can see all of the different constraints that we used by looking at all these icons. So midpoint, horizontal, vertical, equal constraints appear. Now we're going to finish the sketch, and we're going to use our revolve tool. So click on the revolve tool, and you're going to select this main profile as well as these profiles. You don't want the inner ones because we're going to add patterns in between. Now for the axis, we're going to select this blue axis and make sure the operation is new body and the angle is a full 360. Press OK. Once you do this, you'll see our tire is now almost done. It was revolved fully around, and then we can see our treads that we made with that side profile as well as the inner edges. Now we're going to start making our actual wheel. From here, we're going to want to add more treads. We're going to make an offset plane from this bottom face up 80 millimeters. From here, we're going to start adding the treads. Make a face, or make a sketch on this face. And in order to do anything with the sketch, we will need to project it. Projecting it, of course, includes that geometry. So we're going to click P and then click every one of these faces so that we can get it included in our sketch. And then press OK. You can see it created a number of lines. And then we can, of course, build off of these lines. We're going to start with the lower gap, the lower large gap. we're going to create a line from the midpoint of the top of this gap down to the lower section. If you want to turn off that body, you can do so to make it easier to look at. So once we have this line, we're going to create another line from the midpoint of the bottom to the top. So we've created the first line from the midpoint of the top to then the bottom, and then we've created a second line from the midpoint of the bottom to the top. We are then going to make these two lines parallel to each other. So if we try to move one, you will see how it changes the angle and the distance. This is another example of angle defining the distance. We're going to apply a 2.5 millimeter distance between the two of them to constrain the angle, the distance, and the position. Once we do this, we can't move it, which means it's fully constrained. From here, we're going to add another part of the tread to the bottom gap, doing the same strategy. Start the midpoint from the top section of this gap to the bottom section. And then we're going to do the bottom section midpoint to the top. This constraint is in the way, so I'm going to move it. We're then going to make them both parallel. And we're going to make it 2.5 millimeters. Actually, this is failing to resolve. This means that we can't actually make it 2 millimeters. So I'm going to make it, or 2.5. So I'm going to try 2. Yeah, so sometimes when you make constraints, it doesn't always work. So we're going to sort of gauge where we want it. Actually, here's a strategy that we can use. We can create a construction line straight down from here, and then we're going to make this vertical using the horizontal vertical constraint. Once you do that, the ends of it are going to be essentially across from each other. And because you've defined that, it defines both of these. Now that we have half of the treads done, the easy part is next. We're just going to create a line like this, and then define it just so it's constrained. You can make it a construction line or a normal line, but now we are going to reflect these lines that we just made using the mirror tool. Select this line that we just made as the mirror line, and you'll see it replicates it on the other side. Press OK. From here, you can finish the sketch. Now, make sure your wheel is turned on so you can see it, and we're going to use the emboss tool. We've used this for other projects, such as with the bottle project, but we're going to use it again. So, one thing to notice with the emboss tool, it can only be used on one profile. So technically we have 5 different profiles here. Actually, we want to add that center one. I forgot about that. So we're going to go in, and we are just going to make another set of treads on the inside, and we're just going to connect it from these midpoints to each other. So we want to add the center treads. This, fortunately, right here it's midpointed. It's not actually midpointed here. So what we're going to do is we're going to use the coincident constraint, and we're going to coincident it to this line. Now we also see that the angle is not constrained, so we're going to make that angle horizontal. And now the sketch is fully constrained. Now we're going to make sure our wheel is on, and we're going to start making our treads with the emboss tool. The emboss tool is going to use our sketch profiles, and it's going to project them onto a face with a certain amount of depth. So we want to do it at 1.5 millimeters. So it's flush with the other treads we added previously. Now we're gonna have to it gets a little repetitive, but we're going to have to make this emboss on each one of these profiles. Make sure every time it has a 1.5 millimeter depth. And this is because you can only make one emboss per profile. Okay. Once you have that, you will see in our timeline we have 5 different embosses for the 5 different treads we added. Now, because we want this to go all around the tire, we're going to use the circular pattern tool. We're going to then select, instead of bodies, we're going to make it features. Now, features allow us to go into our timeline, and then we can select each one of these embosses in the timeline, and then we can then use the embosses as the feature that we revolve, or circular pattern. So you're going to select all 5 of those as the objects, and for the axis, we want to select, you could either select the same profile we used for the revolve, the same axle, the same, what do you call this? I mean, the same line, I guess. Or you could also select, like, this face, because it's also, the midpoint of this face is also on the origin. For the quantity, you're going to set the quantity to 75. Now, this might lag a little bit, and it might give you an error where it says too many pattern instances. This is because the circular pattern tool has different compute types. Try to do it as optimized. If you do it as any other ones, it might lag out, and depending on your computer, that can be an issue. Press OK. Give it a minute to compute it, but what it's going to do is it's going to take those emboss features, and it's going to make 75 of them all around your wheel, or your tire. So that is going to actually give it treads all the way around. So as you can see, it is loading here. Now, once your circular pattern has loaded, this here took about like 2 minutes, you will see that we now have treads all the way around our wheel. Now that the tire is completed, we're going to start working on the wheel. Create a sketch on the side plane that cuts the wheel in half, just like what we started on. Now, when we create a sketch like this, it's very difficult to see because the wheel or the tire is in the way. So we are going to actually leave the sketch. Actually, you don't have to leave the sketch. You're going to go to this Inspect tab right here, and you're going to go to Section Analysis. Section Analysis will cut your entire design in half, and it will show you essentially a cross-section of your design. Once we do that, it's now easier to see, and we can start making our wheel. Now, before we start modeling, we need something to model off of. So, we're going to use the Project tool to project these edges right here, including the bottom ones and the intersections. Now we have something that we can build off of, basically, to create our tire. We're going to go ahead and we're going to make all of these lines. We're going to make these all construction lines. Now we're going to make normal lines, and we're going to connect all of these sections. Once we have this, we're going to then offset each of these faces, or sketch objects. We're going to do it 2.5 millimeters. Once again, like we saw in the original sketch, these endpoints are not constrained. So we are going to make lines connecting the two, and we are going to make them vertical. Now that our sketch is fully constrained, we're going to then revolve this. Make sure that the operation type is new body, so it doesn't actually join it to the tire. Now if we turn off our section analysis, actually, something in the sketch is unconstrained. We're going to see if we can find it. So one strategy, if your sketch is unconstrained, is you can open up the console by pressing Ctrl-Alt-C. Fusion is a built-in text command console, and if we type sketch.show under constrained and press enter, we can actually see what points are unconstrained. So right now, the points that are unconstrained are this line. So when we made that offset, this will come up sometimes. Whenever you offset it, dimensions get deleted for certain lines. So this line, we actually have a line right here that is offset from this line, and it is not constrained. So you can see this by it's mostly its distance that's unconstrained. So what we can do is we can set this equal to the line it was initially offset from, and by doing that, it then makes this line constrained and this line constrained. And you can see that the entire sketch is completed because it is fully black and it has the lock icon. You can then finish the sketch, and that didn't mess up anything parametrically, so we're good. We're then going to turn off this cross section by turning off the analysis folder, which you see came up underneath our design browser, and we're then going to create another sketch on the side plane here. We're going to project the inner rim of the wheel, and we're going to start making the spokes. We're going to make a vertical construction line. Actually, first we're going to make a circle with a diameter of 10 millimeters. We're going to make another circle with a diameter of 30 millimeters. We're then going to make a vertical line, vertical construction line, that connects the inner midpoint to the outer rim of the wheel tire, or the wheel itself. We're then going to create a line like this. Make sure it's not a construction line, starting from the inner rim to this wheel. Now we need to constrain this line. This line's position, angle, and distance are not constrained at all. So we need to do some things to make it constrained. One, I'm going to set this angle right here to be 2.5 degrees. So it's a really small angle, but that effectively means that it will always be at this angle. So now that that's constrained, we're going to actually reflect this across this line. Now, when we reflect, similar to the offset tool, sometimes the endpoints will get off of the line that they were on, so we then have to redo these. Okay, so it's telling us that the sketch geometry is over-constrained, meaning we don't actually need to do that. What we're going to do now is we're going to set this distance here to be 5. Once we do that, it's going to make our sketch fully constrained. Now, let me just explain why the spoke is constrained. Basically, we have defined the angle which is 2.5 degrees. So it will always be 2.5 degrees compared to the horizontal, which this line is horizontal. Now, by applying this 5mm constraint, it is comparing it to itself. So when I mirrored it and I made it 5mm, these two lines are equal to each other because of the mirror constraint. And because they're both 5mm away from each other, the only position that is 5mm away from each other is the position they are in. So if I got rid of this constraint, I could drag them out wherever they need to be. But the only position where the top endpoints are 5mm is at this position. So Fusion will automatically apply the correct position it needs to be in based off of the distance that you apply. Now we're going to revolve this, or use a circular pattern to revolve this. So we're going to select these two lines, select this as the center point, and we're going to select 5 spokes. Now we're going to create the bolts. We're going to create a center diameter circle with a diameter of, let's say 3mm. Now we're going to make another construction line from this 30mm circle to the 10mm circle that we've created. It's hard to see, but it's there. And what we're going to do is we're going to apply a midpoint constraint between this circle and that line. Again, if it's hard to select it, you can hold down and you'll see all of the different objects that you're selecting. So this is the small line that I just made, and then you can also select and find the other line. Now we're going to do the same thing. We're going to select that object. For the center point, you can select this circle, and then for the quantity, you're going to type 5. Then press Finish Sketch. Now we're going to extrude this, all these profiles, up to this edge. Now normally, tires aren't flush like this. They're not fully flat. So what we're going to do is we're going to make a side profile and we are going to revolve it to bring it down. So create a side sketch on this plane. Go ahead and turn the tire off. You don't need to see it. Now what we're going to do is we're going to select this line right here. And then this line right here in a projection. Press OK. Now we're going to want to determine what sort of angle we want. I'm also going to project this intersection right here. I'm going to create a line down from this inner diameter, and I'm going to press OK. I'm not going to constrain that line yet. And then I'm going to make a secondary line from this line that's down out to this line. I'm going to then finish the profile with a third line on top. Now the sketch is unconstrained. So if I want to constrain this, I have two options. Either I can set the max distance that I want it to go in, or I can select the angle I want it to make.
Your Google Home isn't set up yet. To get started,
My bad, guys. I'm going to then create an angle like this, and I'm going to set it to be 5 degrees. 5 degrees seems okay, so I'm going to just finish the sketch. Now I'm going to go to the revolve tool, and then I'm going to click on that profile. Click on this for the axis, and then we're going to see that it actually revolves that as a cut function. So we were able to then make it almost bowed inwards. Now let's say I wanted to make that angle bigger. I can go in and change this to 10 degrees. This might be a bit excessive. Yeah, that's a bit excessive. But then that allows us to change what we want. From here, you can go around and you can apply fillets to all of these edges. So I would apply it to the back edge as well as the inner edges that the tire spokes come into contact, or the wheel spokes come into contact with the edge of the wheel. And you can sort of just drag this out to see where you want it. I think 5 is pretty good. And then you can show this other body, the tire body. Now one thing that we're going to want to do is we're going to want to apply some textures. So if you press A, you can pull up the texture library. I'm going to look up aluminum. We're going to find a bead blasted aluminum. I'm going to drag that onto the tire. And I'm also going to look up ABS. ABS is a good just starter texture. So I'm going to drag that in here. I'm going to edit it. And I'm going to make it black. Actually, Fusion has a rubber texture. So if you just look up rubber, I'm going to download the hard rubber. And I'm going to drag it out to my tire. Now the tire is done. So this sketch, this project is pretty complicated in terms of the sketches. If you go into the sketch folder, you can see that all of our sketches are constrained. So if you can understand everything that happened in this video when it comes to sketches and constraining them, then you are well on your way to mastering Fusion. Sketches are really, really important, and constraining them is even more important because, like you've seen, if I want to go in and change any of these parameters, I can do that. Let's say I wanted to add or get rid of a spoke. I can go in to this sketch and I can then change one of these circular diameters to be 4. Finish the sketch. Oh, sometimes it'll mess up extrudes, so that's actually what happened here. It messed up this initial extrude. So you just have to get rid of that, and like you can go in and fix it like this. And then that should actually update it. Yeah. Sometimes it will give errors because this is projected off of other things. So what you might have to do is go in and edit these other features and make sure that they're properly updated. Because if they're not updated, they will give errors. But if you constrain everything, you can go in and basically like edit and change things really, really easily. And that's important if you ever want to do any professional engineering applications. For example, in robotics, you will go through several different variations of a single design, and being able to go in and change specific dimensions and parameters is super important and super necessary when going through the engineering design process. So that's it for today's video. Make sure you understand everything that I've gone through. If you understand everything, then you're ready to go on to some of the more advanced projects.